Imagine a place on our planet where no human has ever lived. It is a realm of profound silence, absolute darkness, and immense crushing force. This is not another planet or a distant moon. It exists right here on Earth, hidden beneath the waves of the vast Pacific Ocean. This place is an abyss, a chasm so deep that it holds some of the planet's greatest mysteries. It is a world apart, governed by rules of physics and biology that seem alien to our own sunlit existence. We often look to the stars for undiscovered frontiers, yet one of the most unexplored and enigmatic environments lies in the deep blue heart of our own world, a place that challenges our understanding of life itself. This mysterious realm is the Mariana Trench. It is located in the western Pacific Ocean, just to the east of the Mariana Islands. If you were to look at a map, you would see it as a long, crescent-shaped scar on the ocean floor. The trench stretches for an impressive distance, running approximately 2,550 kilometers, about 1,580 miles in length. While it is incredibly long, it is comparatively narrow, only about 69 kilometers wide, around 43 miles wide. Within this already immense trench lies a point of even greater depth. This point is called the Challenger Deep. Descending into the Mariana Trench is like entering another world, one defined by extreme conditions hostile to most life. The first and most overwhelming force is the pressure. At the bottom of the Challenger Deep, the pressure is over 1,000 times sea level. Imagine the weight of 50 jumbo jets stacked on a single person, visualizing the immense force on every square inch. This pressure would instantly crush most submarines and unprotected surface life. Beyond the crushing pressure, there is the darkness. Sunlight cannot penetrate these depths. By about 1,000 meters, it's perpetual twilight. Thousands of meters down in the trench, there is no sunlight at all, absolute, unending blackness broken only by faint bioluminescence. Accompanying pressure and darkness is biting cold. Temperatures hover between 1 to 4 degrees Celsius. Near freezing conditions force special adaptations. The deep ocean is stable and cold. Slowing metabolic processes, immense pressure, total darkness, near freezing temperatures combine to create one of Earth's most extreme habitats. Despite the crushing pressure and absolute darkness, the Mariana Trench is far from lifeless. It is home to a surprising variety of organisms. The foundation of the deep-sea ecosystem is microorganisms, bacteria, archaea. These tiny life forms are called extremophiles. Instead of sunlight, many rely on chemosynthesis. They generate energy by processing chemical compounds, sulfur, methane that seeps from the ocean floor. These microbes form the base of the food web. Amphipods are among the most common and fascinating creatures, small crustaceans distantly related to shrimp and crabs. The trench amphipods are unique. Some species like Alicella gigantea. One iconic resident is the Mariana snailfish, Pseudoliparus swirae, the deepest living fish on record. A small, translucent, tadpole-like fish, delicate in appearance but incredibly tough. It lacks a swim bladder, the buoyancy organ most fish use. A swim bladder would collapse under this pressure. Life there survives on marine snow, a slow, constant drift of organic material. This scarce but steady supply sustains trench life, from bacteria feasting on particles to amphipods and snailfish preying on smaller organisms. The Mariana Trench is not just a deep hole. It is a dynamic and active geological feature, born from the immense power of our planet's tectonic plates. The Earth's crust is not one solid piece, but is broken into several large plates that are constantly moving, floating on the semi-molten mantle beneath them. The trench was formed by a process known as subduction. This happens at a convergent boundary, where two tectonic plates collide. In this case, the colossal Pacific Plate is moving westward and crashing into the smaller, slower-moving Mariana Plate. The collision of these two massive pieces of Earth's crust is the engine that carved this incredible chasm. Subduction is a simple but powerful concept. When two plates meet, the denser one is forced to bend and slide beneath the other, plunging down into the Earth's mantle. The Pacific Plate is one of the oldest and densest sections of oceanic crust on the planet. As it collides with the younger, lighter Mariana Plate, it is forced downward in a slow but relentless descent. This downward plunge creates the deep, narrow depression that we call the Mariana Trench. The process is incredibly slow, happening at a rate of only a few centimeters per year. This geological process is not a quiet one. The subduction zone that forms the Mariana Trench is a hotbed of geological activity. The Mariana Islands themselves are a chain of volcanoes that were formed in this way. For most of human history, the bottom of the Mariana Trench was as inaccessible as the surface of the moon. Its extreme depth and pressure made it a forbidden frontier, a place we could only measure from afar. That changed on January 23, 1960. On that historic day, two men made the first ever journey to the floor of the Challenger Deep. U.S. Navy Lieutenant Don Walsh Jacques Piccard descended in a specially designed submersible called the bathyscaphe Trieste. Their descent into the blackness took nearly 5 hours, a slow, intense journey into a world no human had ever seen before. The Trieste was not a submarine in the traditional sense. It was more like an underwater balloon. When Piccard and Walsh finally landed on the seafloor, they looked out of a tiny porthole into a world of fine, diatomaceous ooze. They spent only about 20 minutes at the bottom, but in that short time, they made a groundbreaking observation. They saw a flatfish swimming by. For more than half a century after that first dive, no human returned to the bottom of the Challenger Deep. Then, in 2012, filmmaker and explorer James Cameron made a solo descent in his own custom-built submersible, the Deep Sea Challenger. Cameron spent over 3 hours at the bottom, filming the stark, lunar-like landscape and documenting the creatures he saw. More people have walked on the moon than have descended to the Challenger Deep. The Mariana Trench may seem remote and alien, disconnected from our daily lives on the surface. However, it is deeply important to our planet and to science. The trench is a crucial part of Earth's global systems. The process of subduction that creates the trench acts like a giant recycling system for the planet's crust. As the Pacific Plate sinks into the mantle, it carries water, it carries carbon. This process plays a vital role in the long-term carbon cycle, which helps regulate Earth's climate over geological timescales. From a scientific perspective, the Mariana Trench is a natural laboratory for studying the origins of life, studying the limits of life. The extremophiles that live there provide invaluable clues about how life might exist in other extreme environments, both on Earth and potentially on other planets or moons in our solar system. By studying the unique proteins and cellular structures that allow these organisms to survive under immense pressure, scientists can unlock new discoveries in biochemistry medicine. The trench challenges our very definition of what a habitable environment is, expanding our understanding of biology's potential for adaptation. Furthermore, the trench holds a record of our planet's history. The sediments that slowly accumulate on its floor are like pages in a geological book. The journey into the deep is just beginning, and there is so much more to discover.